So you've probably heard the hype. AI is going to completely revolutionize science, right? It's going to design life-saving drugs, discover brand new materials for clean energy, you name it. The promise is absolutely massive. But here's a question. Is the AI we're building actually learning how to be a scientist, or is it just becoming a really, really good student? For the longest time, this is what science looked like. A human expert right there in the lab, meticulously, painstakingly working to push the boundaries of what we know. And the goal has always been to speed this up, to make those big discoveries happen faster and more efficiently. And let's be real, the problems scientists are trying to solve are just mind-bogglingly complex. We're talking about figuring out the intricate dance of molecules, designing new materials literally atom by atom, and decoding the very blueprint of life itself. I mean, these are some of the toughest questions humanity has ever dared to ask.
But now, there's a new player in the game, a powerful partner entering the lab, artificial intelligence. We imagine it as a kind of co-scientist, a tireless assistant that can chew through data and spit out ideas at superhuman speeds. But this brings up a super important question. How do we actually know if an AI is any good at doing real science?
And this is where we run into a big issue, what we can call the book smarts problem. It turns out the way we've been testing our AIs for science might be completely missing the point.
So here's the fundamental disconnect. On one side, you've got the old way of testing AI. It's basically a multiple choice exam, Just isolated facts pulled from a textbook. But on the other side, you have what real scientific discovery actually is. It's messy, it's an iterative loop of coming up with a hypothesis, running an experiment, trying to make sense of the chaotic results, and then doing it all over again. The problem is, our current tests are just hitting the wrong target. They're testing for textbook knowledge, not for the actual ability to do research. I mean, acing a pop quiz is one thing, but being a great researcher, that is a whole different ballgame.
And this quote from the researchers behind this new study just hits the nail on the head. Earning straight A's in coursework does not indicate a great researcher. It perfectly captures that gap, right? We're testing for memorization, not for that spark of genuine innovation.
Okay, so if the old tests are basically useless for this, what's the alternative? Well, this new research proposes a totally new way to evaluate these systems, a much better test for any would-be AI scientist.
It's called the SDE framework, which stands for Scientific Discovery Evaluation, and you should think of it less like a trivia night and more like an obstacle course for scientists. It's built from the ground up to test an AI's ability to get its hands dirty with realistic research tasks.
And the way they built this thing is actually simple, but it's really powerful. It's a three-step process. First, they start with a real-deal research project that actual scientists are working on. Then, they chop that big project up into smaller, manageable scenarios. And finally, they craft questions that are directly linked to those real-world situations. Every single question has a purpose. There's no trivia here.
And we're not talking about some small-scale quiz here. This thing is massive. It has over 1,100 expert-vetted questions that span biology, chemistry, material science, and physics. This is a rigorous, heavyweight benchmark designed to really separate the good students from the AIs that might actually become scientists.
All right, so we've got this new, much tougher test. What happened when the world's top AI models were forced to sit for this exam? Well, let's just say the results were pretty surprising.
So check this out. This is the first big takeaway. On a standard, book smarts kind of quiz, a top model cruises by with an 86%. That's an A. But when you give it the new SDE test for material science, that score plummets down to 75%. This performance gap proves it. Book smarts and scientific reasoning are not the same thing. Not even close. But wait, it gets even weirder. It's not just that the top AI models are having a tough time with these new, harder problems. It's that they are all struggling in the exact same ways. And that points to a much deeper, more systemic problem.
And this chart really tells a story. On a really tough chemistry problem, look at that huge orange slice. Almost 73% of the time, all four of the top models, from completely different companies, got the exact same wrong answer. That screams that they have the same blind spots, probably because they were all trained on very similar data.
Okay, but here's where the story takes a really cool, counterintuitive turn. It turns out that having encyclopedic knowledge isn't always what you need to make a discovery. Sometimes it's about guided exploration, and a little bit of what scientists like to call serendipity.
And this right here is what the researchers call the serendipity effect. And it is wild. On the left, you can see that the AI models totally bombed the textbook questions about a certain type of molecule. They just didn't have the book smarts. But on the right, when they put the AI in a simulation and just told it to go discover new molecules, it performed incredibly well. It's almost like not knowing the right answer freed it up to explore weird, new combinations that led to success. It shows that sometimes the ability to explore is way more powerful than just knowing the facts. All right, so after all of these surprising results, what's the big takeaway? Where do we go from here to build a true AI collaborator for science? Well, the research lays out a pretty clear roadmap. First, we've got to stop just making models bigger and instead focus on training them to ask the right questions. We also have to use way more diverse data so they don't all make the same mistakes. And maybe most important, we need to integrate real scientific tools, like simulators, directly into their training so they learn the actual process of doing science.
Because, at the end of the day, the goal here isn't just to build an AI that can ace an exam. The real ambition is to build a true co-scientist, a partner that can work right alongside humans and help us make that next breakthrough, world-changing discovery.
And that leaves us with one last, kind of mind-bending thought to chew on. Right now, we're totally focused on teaching AI how to pass our tests. But what happens when it finally graduates and starts making discoveries that are completely beyond our own human understanding? What does that future even look like?